Hello everyone, welcome back to my Tidyverse series. So in previous videos, we explored about dplyr and tidyr for data manipulation. Today we will focus on a Stringr package that is designed to manipulate text and string in R. So in clinical dataset, we often deal with AE term, lab text, test codes, and descriptive variables that need clearing, formatting, or extraction. That's where Stringr package comes in. So let's start. Next comes to why Stringr in clinical data. So in clinical data, AE just like AE term like severe pain or headache can be inconsistent. Like lab codes may have extra spaces or inconsistent case. Analysis or TLFs require a standardized or a clean text. So basically, Stringer makes these tasks easy, readable, consistent, especially when you use uh, dplyr pipelines. So why Stringer in clinical data? Clean, inconsistent text. Like if you're if you see moderate in a different format, right? In a uppercase, lowercase, prop case. So in these case, if you want to make it consistent, you have to use Stringer. Extract part of a variable, like you have test name and you want to extract lab codes, you can easily do that. Detect specific term. EE contain like let's say you have pain, severe pain, and you want to extract only the severe pain observations. So you can do that. Standardized formatting, remove space, change case, combine field. You can easily do that with string R package. So we will see each and every example with in R Studio. So you can understand how this string R package works. Next. Next is difference between the Stringr versus base R. So all these tasks, detect text, replace text, you can easily do with the base R functions as well. But why Stringr? Because Stringr package has more better options. In like let's say you are using a str underscore detect. You have so many other arguments. You can modify your text better. So this is definitely useful and it works very good with when you are working with a dplyr package or any tidyverse package. So Stringer is a part of tidyverse, so that's why it goes well with all these package. So when you are working with the Stringer, its function always start with str underscore. So uh, you can easily understand like okay, this is a function of string r because it start with a string and then underscore and then function name. So for detect, in Stinger we have str underscore detect, but with the same task you can do with the base R with grapl and replace text str underscore replace and in base R sub and sub function. With sub function you can do the same task. Definitely you have to do little more steps with base R because every time you have to subset your data. But as you are using the string R function, which is part of a tidyverse, you can easily merge your uh, functions with the dplyr and tidyr very easily. So definitely string R is better and I think faster than base R. If you are working with a complicated and a large data set, so string R will work better. We will see each and every example with the both. Like if we are working with the str, a string R function, then I will show you how you can do with the base R as well with in examples when we do coding part. Extraction text, I extract text with the str underscore sub str with the base. Split text str underscore split str split. This is slightly different. Only a difference is underscore. But this is a base R function. This is string R. Combining test str underscore c and this here in base R is spaced. So we will see each and every function with the example. So let's jump to R Studio so that we can start our coding part and see how this function from string R and base R function works all together. So let's jump to R Studio so that we can start. So this is my Art Studio screen. Hope you can see my screen. My global environment is completely clear. I use the RM command to clear my global environment, and console is also clear. So now I'm calling my tidyverse package. So this is all the package inside the tidyverse. We already covered the deployer and the tidyr in previous video. Now we are focusing on the Stringr package from tidyverse. So it's up to you. You want to call Stringr by separately, like library dot as a library and then Stringr package, and but we will use deployer as well for chaining. So you have to call the deployer as well. So I'm just calling the tidyverse all the packages in one go. So if you haven't installed the tidyverse package, you have to first install, then only you can call the tidyverse library. Now I'm creating two tables like AD underscore base. Both table are same values, everything is same. Only difference is first table I'm creating using the table, that is a part of a tidyverse package. Second table I'm creating with a data.frame, that is a base R function. Okay. What is the difference between the table and the data.frame? First difference is printing is much better in table. Both are table. Like you can use anything for creation of data frame, but table is better, faster, and if you are working with a complex and a long data set, then you have to use. If let's say you have a CSV file and you import the data and you want to convert something complex data to a data frame, you can easily do that with table. So table is faster and better. I can show you how. Let's print. First difference is printing is much better in table. I am printing this table ADAE. Okay, you can directly select and run, but I'm just adding one more command, that is print. So I'm just printing this table. Okay, first I have to create. Okay, this one done. This one done. Now I'm printing. So this is the table output when I print the table. Now I'm using this, okay, underscore base. This is my second table. So this is the output from a this ADE underscore base, and this is from the ADE. So with the table, I'm getting the character data type as well with every variable. But in when I created the table with the data dot frame, I'm not getting these kind of output. So this is much better. It will give you side by side the data type of each and every variable. No need of going somewhere to check, okay, what is the data type of this, and no need of writing the str this AE underscore base. You can directly, okay, by this you can see, by using the str command you can see, but you have to write the two command, or you have to write this separately. But with the table, printing is so clear that you can easily understand, okay, this is or if you have, this is very small data set, you are getting each and every observation. But if you have a very big and complex data type, then you can see the difference very easily, that table is printing my data set in a console in a very clean way, instead of that if that data frame is made up with data.frame command. So table is better in printing, and most important thing, like for data.frame you have to specifically mention string as factor is equal to false, because sometimes data.frame function do like convert our character variable to a factor form that we don't want in our output. Let's say you are working with a character data type, but you are not getting the required or expected output, because if your data is made with data.frame count, it will convert your character to the character variable to the factor sometimes. Then you have to specifically mention that I don't want my character variable to be in factor form. That's why I'm giving the false. But people will not do that. If you mention a observation, then it will give you the correct output. Or you want the output in a factor form, then you have to go use the as dot factor function to convert your character output to the character variable to the factor form if you want. But that data dot frame do like directly convert your character to vector. So this is the difference. Like you have to mention string as factors is equal to false for the data dot frame, but with table no need of mentioning that because it will keep your data type intact. It will not convert your character data to the factor data. And Tibble goes well with the all the other tidyverse package like with dplyr. Like Tibble integrates perfectly with dplyr, tidyr, stringr, ggplot2. So this is better. And more important thing, let's say you want to give this use subject ID a different name. Let's say I want to give you subject ID of a subject. Let's a big name you want to give sub. Uh, okay, sub subject ID of a sub. So I want to give this as a name. You can easily give that in Tibble, but not with the data dot frame command. How you can do that? You have to use this tick mark here and tick mark here. Now run this. Okay. Now print this. Look, you are getting use subject ID of a sub. So in Tibble you have option to give any name. Even in SAS we have restriction. We can't give these type of like we can't give space in our variable. But with if you are creating a table with a table, you can easily do that with using the two tick marks near the tick marks near under the escape key. So you can use these two tick mark for the creation of a longer variable name if you want. That is not allowed in the as standard for the C disk, but uh, if you want to, you can easily do that. You have option in Tibble, but not with the data.frame. It will give you the different output. Let's try this in this. I'm just adding the tick mark and I'm saying of a sub. Okay. Now run. It will give you some different output. We want spaces, right? We want spaces, but it will give you some other thing. Now print this. Now it is giving me should use subject ID dot of dot a dot sub. But definitely you are getting like you are getting some big name that is not allowed in SAS. With these two tick mark you can do that, but with Tibble you will if you are giving the space you will get the space. But here you are giving the space, but you are not getting the spaces. You are getting the period. Uh, so, uh, so this is the difference between these two, and yeah, definitely you will. And with table, you are getting the clear column names and everything, but in data dot frame, you are getting only the name, not the data type. So these are the some difference between the tables that we created with table and the data dot frame. But anyways, you can use any method for the creation of this table. I will use this ADAE table for the showing the functions of Stringr and ADAE underscore base table for showing the function from the base R. And this is for Stringr. So that we can make some difference with these two tables. Okay. So let's start. So first function we have to discuss is detect row containing a pattern. I forgot to discuss about the variable. Okay, I'm using use subject ID AE decode AE severe. So basically, we have to look for the string. That's why I'm using the AE dataset. That is the mostly we store string in AE dataset. So, I'm using this example AE decode. In that, I'm using some headache, nausea, severe pain, mild headache, and AE severity mild moderate because we need to work with the string part. That's why I'm using this example. So let's start. First is detect row containing a pattern. So for that, I will use dplyr and stringr both side by side. So first you have to write. Okay, first example is for stringr. Stringr. Okay, in that I'm using ADAE pipe symbol. This is this data frame I'm using ADAE. Okay. and I'm saying filter. This is the function from dplyr that we already did from in previous video. So str underscore detect. This is a function from Stringr. You can see str detect is like Stringr function. In that I'm saying this is the variable I have to use. Okay. And in that I'm saying detect this pane. Okay. I'm using this. Just run. Okay. Okay. This is the I in str detect you gave the variable name. This is the variable name, and this is the data. We already connected this ADAE data with this function by using the pipe symbol from dplyr. So I'm saying use this variable and detect this string is present in any observation. So only one observation has this severe pain. That's why it's giving me the only this observation. By this, you can easily filter your data if you want to filter with text. So you can use str underscore detect this text. You have to give any text. You can give any text. And let's say you want to search for the headache, you can easily search any text. If you provide any string, it will search, detect in that particular variable and give you the output. So you can use it. Or if let's say you are searching for headache, you gave this, and but let's try copy and paste. Oops. Okay. Hmm. Now search. So it is giving me this output, right? Note the this one. It is not looking for this. This is very case sensitive. So let's say you want to detect both headache and a mild headache. Then you have to go for the regex function, regular expression. That is, I already made even video on that. You can watch that. Then you can understand how we ignore our case. If we want to give, if we want to search for both the headaches, despite of the um, case. If you want to ignore the case, then you have to apply regex, not the str detect, because str detect only those which str underscore detect is a very case sensitive. It will detect only that particular string only, not not you can't avoid any case thing. So you have to go with the base R function, that is regex. You can watch that video. Definitely, it will help you to understand how we ignore cases when we are working with a string. So, okay, this is the way we use str underscore detect using the string R package. But let's say you want to do the similar function, similar output you want to get. Then with the base R function, how you can do that? Let's try with the base R. Base R. Okay. Okay, for that we need to fix this first because we don't want our variable to be in this format. I want use subject ID only. So just run it again to update. Okay, let's check. Okay, now we are getting the use subject ID. Now I will use this base and ADAE underscore base table for base R functions. I'm using this ADAE underscore base. Now I'm subsetting. In base R, if you want to work with the data frames, you have to subset again and again. This is the major problem. That's why we go for the packages because base R function can do the similar task, but in more steps and you have to subset your data again and again. For every steps, you have to subset your data with each and every variable. So now I'm applying the grep L. Let's go for the grep L. Even in my regular expression video, I explain all the functions like grep, L, and grep, and all. If you want to learn about regular expression, you can go and definitely before watching this Stringr video, it's better to watch that regular expression video because both are working with a string. So it will help you to understand how base R function work and how string R function work. You can make a difference or comparison between these two. So it will help you definitely. Now I'm applying the grep L function and I'm looking for the this pane string and for which variable I have to look AD code, right? Now I have to subset that ADAE underscore this in this table. I want to subset this ADAE decode variable and I want to subset it for all the variable. Now look, we are getting the similar kind of output. This is and this both are giving me the same output. Okay, and let's go for the headache. Now I want to look for the headache. This one. Now, so similar, different string. Okay, I'm getting this. Let's say I want to ignore case. Here I can apply the ignore case. Um, in the inside the this. Now I'm saying ignore underscore case because look, this is a function of grep L. Oh, sorry, argument of grep L. So I'm saying capital P. Now run. You will get both output. Okay, run this. Look, I'm getting both output. This one, oh sorry, this one and this one. Because we we are not considering the case. Just give me output in all the observation which has headed as a string. So we are getting the two, this one and this one, and not considering the case. So by the base R function, you can do that, but string R is specific with the case. Whatever you provide, it will give you the output. So this is the function of detect row containing a particular string or a pattern. You can easily do that with both the thing. Definitely in base R you have to subset your data, but in string R you just combine with the deployer package and you can do that. It's easy, right? Just replace a specific pattern. Okay. For this, first I'll just copy this. First I'm showing with this string R direct function we have str underscore replace we have ADAE this data for the string that I'm using and connecting it with the deployer package, right? And using mutate because I want to create one more from let's say I want to create one more variable or I want to make a change in this AE severity variable. I want to change this to let's say instead of uh, uppercase I want to change it to prop case. We can do that. Okay, I'm using mutate. So many other way so you can do so many ways are there to do the same task, but as we are focusing on the str stringr package, that's why I'm using the stringr functions only, but so many other way you can do the same task, so it's up to you. Now I'm saying KE severity and okay. In this I am changing str underscore replace. Look, this is the function. This is a function from stringr. Um, and if you want to ask for help to if you want to see the various argument in that particular function, just add question mark or write help. Um, let's say I want to look for about this function. Just question mark, paste and just run. Here you will get complete how many various argument. This is str replace and this is str replace all. Okay, so by this you can see so many examples are there. It will help you definitely if you learn more about that particular function, how many arguments we have and where we use all these. So by this you can take help from this. Now I'm using, let's say, I'm changing this. I'm changing this string to, okay, in this format. And in which variable I want to change? I want to change in ADAE, this data frame, again, dollar symbol. Oh, okay. We are working with the string now, no need of subsetting, right? Just this, done. But we have to provide variable, AESEP. So this is the variable and this is the data. No need of subsetting. Okay, just run. Look. Now we are getting this instead of caps lock. Instead of capital moderate, we are getting in a prop case, right? We replaced this text to in this format. So you can easily use str underscore replace to change or modify any string to your requirement. Now I'm using how we can do the same task in base R. This is for base R function. Here I'm using ADE. Okay, ADAE underscore base. Okay, and subset AE severity variable, because I'm modifying in this table and in this variable. That's why I'm assigning the new value to this the same variable so that we can get this kind of output. So I'm saying sub in that this is my original one. Now I want to change to this one. Okay, and I need to again subset because okay, A D A E, this data frame, dollar symbol, and this variable. Okay, this is a base R function for replacement, substitute, right? So now run. Check for this table now. Now it's changed to prop case instead of uppercase. So by this, I'm changing and assigning to the same table. By this is the base R way of changing and assigning, and this is the string R case with dplyr package. With the use of mutate, we can change as well as assign to the same data frame. So this is the example for the replace a specific pattern. Okay, you can change anything. Okay, like let's say you want to change all the headache in a uppercase. You can easily do that with just adding in a this str underscore replace function, and you can do that. Next function is replace all occurrence of a pattern. Okay, for that we need to use this function replace str underscore replace underscore all. So let's look with this example. Okay, we have severe space pain, mild space headache, right? Let's say you want to add underscore instead of space in this text, right? In these two, how you can do that? Or any observation, if you have space between the two words, then you can change to anything. Like if instead of space, I want to give underscore. I want to connect these two with the underscore. How we can do that? Just write AD, AE. This is again, let's add this so that we can make a difference. This ADAE declare. In that I am saying mutate. Just copy this. It's completely same, no difference. Okay. Now I'm using str underscore all. Wherever this space is present, okay, wherever this space is present, change it to underscore. Done. Just run this. Look. Okay. We are not using the correct variable. We have to use AE code. Then only it will do now, because in AE severity we don't have any two words observation, right? That's why it's not giving us any changes in the output. Look now, look. Severe underscore pain, mild underscore headache. Instead of spaces, we are getting the underscore. So by this, you can replace all your string uh, and you can modify on all location, like on all observation in one go by using the str underscore replace underscore all. Okay, now base R. How we can do the same thing with the base R function. So in that we need to just we can copy paste this and we can change the variable. We have to work with the AED code, right? And here as well AED code. Now we want to change all the space with the underscore, and we have to use, instead of sub, we have to use the G sub. This is the difference. With this function, we can replace all the spaces in AE code variable with underscore. Now run. Now check with this data frame. Look, we are getting the same output as we are getting with the str underscore replace underscore all. So this is the difference, and this is the function G sub, which is equivalent to the str underscore replace underscore all. This is very useful thing. This is all regular expression function, and this is Stringr function. So by these two, we can replace all the occurrence of the pattern. Next is extract part of a string. Very important, very useful for the clinical data, because in clinical domain, we usually extract strings from, like, let's say, from any text, right? Any verbatim variable, we extract part of a string or part of a meaningful string. So it's very useful. In this, first we will see the example of stringr here. And in stringr, we have function str underscore sub. So for that, AD, AE, and I'm mutating some new variable, mutate. In that, I'm mutating, let's say, AE underscore short, anything you can, str underscore sub, just like sub str we use in SAS, right? So we have str underscore sub for stringr package. Now I'm using ad decode, ae decode variable, and in this I'm extracting, let's say for this I'm extracting first five, 1, 2, 3, 4, 5, this much character. So I'm giving, this is similar to substr function in SAS. Okay, just run. Now we are getting first five character from AE decode we are extracting, right? This is a Stringr function, very important for clinical domain. We usually use these kind of function for working with the string in our data, because in many domain we get verbatim variables. So in that, if you are working with uh, text variable, then you have to use the str underscore sub for extract some meaningful data. Now about the base R, how we can do the same task with the base R. We can easily do that. And in that, we have similar function as we have in SAS substr. For that, I'm using, okay, let's write it again. Okay, AD, AE, this data, and I'm working with subsetting. Definitely, we are using the base R, then we have to subset. We have to tell R that we are working with this data. But as packages like more smart and uh, we can connect our step using two different packages, then no need of subsetting again and again. But for base R, we have to tell again and again that we are working with this variable. Okay, now I'm creating one more variable. One more variable. Let's create this one only. Okay, and I'm using substr. This function, look, this is from the base R. Okay, now I'm again subsetting ADAE base dollar symbol AE decode. Okay, and I'm saying I want first 5 character from each observation. Now run this. Look, we are getting right same, but here we are getting okay. Here we are getting in a, this like this one and this. Why we are getting this difference? Look, here we are getting the underscore, here we are not getting, because in our AE code we are not having underscore, but here in AE code we are having underscore. But when we did this step, when we did this underscore step, we assigned this value to the, we updated this data directly, right? In this, we updated in this uh, ADAE underscore base, right? But in this, we did the change, right? But we are not assigning in this case. If you want to assign, you have to write ADAE and then assign and then run. Okay, now check with the this ADAE data. My bad, I think we are changing in a wrong example. We have to change in this. Okay, yeah, in this we are assigning this underscore for AE decode for ADAE underscore base, but we are not assigning in this case. We have to assign here ADAE and assignment, then run. Yeah, now run ADAE. Now we are getting right. Now run this. You will get both output similar. Now run this. Okay. Now I'm getting these both are same now, right? Because yeah, is this for yeah, this is for table, right? Correct. So now we are getting the similar output. Previously we were not getting the similar output because in the previous step we did changes, but we didn't assign that to the main table. That's why we are not getting underscore, but now we are getting right. So this is the extract part of a string. We can do with the string R package using this str underscore sub, and with base str sub str. With sub str you can do that. So if you are working with deployer and tidyverse package, using string str underscore sub is better option. But let's say if you are not working with any package, you are just working with the base R, then sub str is more than sufficient because it's completely similar to any other like if you're like in SAS you use substr, it's completely similar, so you can use substr directly. But if you are working with some other package, it's better to use the package str underscore sub, so it will go well with the dplyr and other tidyverse package, so it's better. Now coming to next, split strings into a components. Okay, so what this function will do, in this function, split multiple word AE term into a separate component. Let's say we have severe pain, it will change to severe and pain, different component. Let's see with the example. Let's start. So here I am AE, and I'm mutating AE underscore split is equal to, I'm using str underscore split, this function from Stringr, and variable is AE B code, and wherever is space is present, I want split there. Okay, now run. Look. Okay, now we are getting in a list form, right? Okay, we are getting like one character for everything, because by default we gave space, like space. We said okay, it's our splitting component is like space, but in this we don't have any observation which has space, because we change it to underscore. Let's change it back to space. Okay, here I don't want to update this table, so I'm removing. So now check this table. Now we have again how to update. Go up and again create this data. Now run ADEE. Now we have spaces instead of underscore. Now run this. Now we are getting, look. This will give you how many character you have with this space separation. Okay. For the first, we don't have any two words that is separated with the spaces. That's why it's giving us one in this format. So by this you can judge, okay, this observation, this variable has two component that is separated with the space. So we so that we can, by this we can easily judge and work further for our analysis. So sometimes basically this is very useful because it creates a list column where each row store a multiple word as a character vector. Okay, so this is powerful because we can extract word, analyze text, or even expand them into a multiple rows. How we can do that? We can use, okay, first we am just assigning this new variable to the previous dataset. Just run, and now I'm using ADAE, and okay, so sorry, yeah, ADAE, and I'm unset unnest. This is from tidyr, but I'm just telling you how we can use this for further analysis. So I'm just using unset. I'm doing with AE split, this one. Okay, now I want to show you the output. Look, this is the output. I'm getting in a look. This has two words, right? Two component. So and by with this unnest, I'm getting, this is from tidyr. I'm getting severe is in a different observation, pain is in different observation. So by this we can get different multiple row with expanded components. So these are the two components, I'm getting the two rows. These are the two component, I'm getting the two different rows. So definitely row increases, but we can easily work for the further analysis if you want this kind of output. One thing is this: you can use unnest, and by this STR split, you can split the observations in different rows. Okay, now one now go to let's say you want to you have two components, right? In this you have two components, severe and pain, and in the output you want severe, right? In the output, in the new variable you want to create, and that you want this, you want to extract this severe, and you can use substr or uh, str extract function as well. But how we can do with this split thing? We have to apply ADAE. Okay, in that I'm creating one more variable, ADAE. It's a bit advanced thing, but I want to show you use case of this str underscore split mutate. I'm creating new variable, that is let's say AE word, anything, any variable. In that I'm applying, I have to use apply family function if I want to extract this part, this component in a new variable. So I have to use sapply if I want to um, use this str underscore split. How we can do that? Okay, for that, sapply, this is a base R function, and this variable, okay, and then tick mark this and first. Let's first run, then I'll explain you what this means. Now run this. Look. Why this we are getting this? This is the variable that we created here. Now I'm using this variable to create a one more variable with the first component. I'm extracting this first component out of these two component, right? So what is the meaning of this? This is as apply function, and this is a function. So basically this is completely equivalent to, let's say, this is for like subsetting, right? Let's say I have one vector x, and I want to subset first element. So I write like this, right? So this is completely equivalent to tick mark this and x first. So we are saying this first. Why we are not writing x here? Because we already attached our data with the deployer function. That's why no need of writing that particular variable name, because we are working, we already said, okay, this is the variable we are working and this is the data. We already attached both. That's why we are not explicitly mentioned here. So basically, we are subsetting our data. This step and this step completely equivalent. When you are working with supply family, this is the function you are using, and what you want to subset, that is the first element, first component we want to subset. That's why we are using the this one. And let's say you want to use the second. Let's try now. Run. Look, we are getting the pain, headache. This is the second component. We don't have any second component for this. That's why we are getting the NS for these two. But we are getting the second component for this. So you can easily do that. Or you can use the tail function as well. We have tail function. In that tail function, what we can do, okay, just copy paste this and change it to new variable. That's I want to create this, and here tail and first. Just run. Now run ADAE. Look, now we are getting the this and this. With this tail, right? You will get no. You are not getting NH. You are getting the first two observation as it is, because they don't have any tail component, but they have, that's why it's giving the tail component. So this is better, right? If you don't want any in your output, so you can use this way. So you have to apply s apply to use this output by the str underscore split. So using this str underscore split, you will get the output, and you can use this output for the further analysis for getting the outputs. So this is all about split string into the component. Next, concatenate columns. How we can do that? It's very simple and very important, as we use concatenation in SAS. Similar way, AE we can do in R. So I'm creating one more variable in that AE. Let's say underscore anything from a underscore label. I'm using creating one more variable, and I'm saying str underscore c. This is a function from string R, right? For concatenation, and I'm concatenating these two variables, this and this. Okay, so directly we can write AE decode this with AE severe SCV and separation SCP. What's the separation we want to use? Let's say mm, this. Anything you can use, star or anything. Just run. Okay, look. So, okay, just go to the assign this value to the ADE so that you can easily see. Now, run and print this. Okay, go to the ADE. Yeah, this way. This is the new variable that we just created for concatenation, and we concatenated this headache with the mild, nausea, moderate, severe pain, severe, mild headache, mild. We concatenate with the this symbol. So hyphen, right? So by using Stringr function, you can concatenate using the str underscore c. Now how to do with the base? Okay, we missed, I think, for this one. This base R function for this splitting string. Okay, we will do. Let's finish this concatenation. How we do for the base R. This is for string R. Okay. Now coming to the base R concatenation. Base R concatenation function. So how we can do AD AE. This is base R dollar symbol. I want to create the same variable in this both table. So I'm using the same name signing, and now I'm using the paste function. We have two functions, paste and paste 0. So it is similar like we have catx, cat s, right? In SAS, similarly we have paste and paste 0. In paste we have separate options, sap, and you can give any separation, like in cat x we give, and in normal cat we have to provide with quotation mark. Okay, like let's say AED code, then we want hyphen, then we have to give quotation. So instead of giving separate option, we have to give after every concatenating variable or any concatenating uh, text. So these are the little bit different you can see, but you can use anything according to your requirement. With the uh, both have different arguments. So I'm using paste. In that I'm saying ADAE base, and I'm have to subset this, and again similar thing ADAE base. Oops, underscore base and dollar symbol AE severity and except and this. So this, yeah. Now run. Check for the table. Okay, we are getting right. And new variable similar to the this Stringr. So this is a function from the Stringr and this is a function from the base. Generally, we use base or paste function for concatenating things, but Stringr function is also good to use if you want to use. So if you are working with a deployer or all these packages, then Stringr is better option. So first we missed one thing here when we were doing the split string into component. This is the example from again Stringr, right? Now with the base R, we missed that time. So I'm covering now. So for this, what we have to do, ad ae underscore base dollar symbol, and I want to create this variable. So I'm just copy and paste here, and we have str split. No, just only difference is this was a function from string r, right? Only difference is without we don't have underscore for the base r. Okay. Now I'm using adae underscore base. On which variable I want to apply this? On ad decode, and this is the yeah, this one. Now just run. Check this. Okay. Go to this. So this is with the base R we are getting. Okay, wait. I think the same thing is happening with this as well because we updated our ade underscore base data frame we updated with underscore in this. So just go back and rerun this again. Now run this one. That's why we are not getting. Now check this. Okay. We are running the wrong code. Okay. Yeah, this one we have to run. Now print this. Now look, we are getting this. Go to this and now look. With the base R function, you can easily see how this is creating a basically how this is creating a new vector kind of output in which we have two components, right? So this is creating because this has two mm, words and it is splitting it to a new vector kind of output in which you have two components. Now you can easily work on this vector, right? So this is very important and this is the way we use str split using the stringr package, and this is str split from the base R. So these are the two functions. By this you can split the string into the components. Okay. Now come to the count occurrence of a pattern. So in this we count. I can show you with the example. Okay. Now we are focusing first on the stringer here. ADAE mutate, and I want to count the pain. This go to the this one pain. How many time pain comes to in this variable? Okay, so I'm just let's say pain underscore c as a new variable I'm creating, and in that I am str underscore count This is a function from Stringr. I'm using AE decode. This is a variable I'm using and which string I want to count. Pain. Okay. This is the string. Now just run. Look. For the first observation, we don't have any pain as a string, 0. But for the third, we have one time pain. So by this, you can, if you are working with a long text and you want to look for how many times this text comes, so you can use the str underscore count function to check how many times this mm, word repeat or this string repeat in a any text. So this is the string R function. Now how we can do with the base R? The same task we can do with the base R. Okay, with the base R you have base R. This is very long and tedious process, but let's try. AD, sorry, AE, AD, sorry, I'm confused. AD, AE and underscore base. On this data set we will work dollar symbol, but variable we want to create this one, so I'm just copy and paste here. This is a bit complex, so if you understand, that's really good. If you are not able to understand, that's completely okay, because you have straightforward function that is str underscore count, because we have to rely on apply family function as apply, and we have to create one more function inside the as apply, then only we will get the same output as we are getting from the str underscore count, because this is a straightforward function. You can apply directly. This is more than this is sufficient, right? No need of going to the base app, but I want to show you, that's why I'm doing apply as apply. I'm and g reg. This is a function I want to use. These are the two function, right? So this is the function expression I want to use, and now I'm saying what I want to look for this, right? This is the string I want to looking. I'm looking. So AD AE subset with AE decode, this one, okay, and now you have to create one function with function keyword and with one argument. This is the one argument I am giving, and I'm saying if else x subset first is equal to -1 0. If this is true, 0, else length of x. Okay. Okay. So we are getting the same output with this. No need of going in that much deep. This is not useful, because if you want to count some uh, like you want to count the string, you can directly use this function, right? No need of writing this much and getting the same output, right? So this is just want to show you how we can do the same task in base R. So, but string R package wins here. So because this is straightforward, right? You just write and do. Okay, next is string length. This is very important function we usually use to calculate the length of the particular string, because whenever we apply, sometimes we apply if else statement as well. So we use length as a length statement, a length function. So we can use this function string length. We can do that. First example is for string R. Okay, in that I am ADAE. I am working with the ADAE mutate, and length underscore AE, new variable I want to create, and I'm using str underscore length as a function from stringr, and I want to calculate the length for each and every observation in AE decode. This one, just run. Look, we are getting first observation. This headache has 8 character and nausea 6, 1, 2, 3, 4, 5, 6, right? And severe pain 11, mild headache 13. So by this you can extract the length of a observation, length of a character of observation, so that sometime when you want to work for the sub-str and you want to know the exact length of that particular observation, you can use this function and then apply the sub-str function or the str underscore sub function for extraction of the extraction of vectors, right? So this is very useful function, very commonly used in clinical domain. Now how we can do that with the base R, right? If you don't want to use the string R, then you can use the base R. Okay, EDAE, this base, and then I want to create a new variable, that is this one. And how we can do ncar. A function in base R is ncar. EDAE, this base, and subset AD decode this variable, right? Just run and run this one. You will get the similar output as you are getting in the string R package, right? So it's up to you. You want to use the ncar from the base R or str underscore length from string R. So done. This is very important. String length. You can use any. Detect string starting or ending with a pattern. Okay. For this, let's say you want to uh, filter your data from AE decode, and you want to filter all the observation that is starting with the severe. Okay, so how you can do that? You have option in string R, just copy. Now I'm filtering EDAE data and filter using deployer and the function str, okay, underscore start, this function. This is from string R, and on which variable I want to apply AE decode, right? This is a variable on which I want to apply this function. What I want to search? I want to search for severe. Better, because I don't want to make any error. So just want this. Look, only one observation has severe as a starting of severe pain, right? So we are getting only the one output as a one observation as an output. So now how we can do this? Okay, let's look for the ending part. Let's say you want to search filter data with AE decode in which any observation ending with pain, let's say. Okay, how we can do that? And any observation ends with uh, string pain. Okay, just copy this, change this to starts to ends. Okay, and pain. Okay, just run. No difference. Okay, only one observation we are getting, that is pain, ending with the mm, pain. Okay, so that this is the two function str underscore starts to search the string in the starting, and end to search the string, that particular string that you are providing in the end, searching for in the end. So these are the two functions from string R. So how we can do it with the base R? So again and again we have to subset our data ADAE, base. Okay, now uh, subsetting. Subset, um, you can use, okay, sub str. In that, in this you can subset ae underscore base and ad decode. This one we want to set subset, and I'm using sub-str. I'm saying apply sub-str on this variable from starting 1 to 6 if in the starting of characters from 1 to 6 is equal to severe. um, same everything, so yeah, is equal to this, and all the for all the in the output I want all the variable. That's why I'm after comma I'm just leaving it blank. So this is the way we subset our data, and in subsetting I'm applying sub-str, and I'm explicitly telling starting from first to sixth word, because this has six character: 1, 2, 3, 4, 5, 6. First six character is equal to severe, then give me output. Explicitly mentioning this. But here you have to just mention the variable name and just the string that you are searching for, or this starts function. So it will search directly in the start, but you have to tell explicitly, okay, starting character from the first to six, if this is equal to the severe, then give me the output just from this. Okay, I think mm, mm, why I'm using the dollar symbol, right? I'm just subsetting this data, right? No need of dollar symbol. Now we are getting the first output here, similar to the this one, right? Now for this ADAE filter ends, I'm not showing the base R example because that is extremely complicated. You have to apply so many time and card option, and then again and again subsetting, and then manually you have to check for the length, okay, 3 plus 1 or these kind of stuff. I'm not showing this example because this is not base R function. For this thing is completely uh, not useful. So I'm just leaving this example from base R. I'm not covering that because this is very complicated. This is still straightforward, that okay, you have to just mention the sub-str. For that you have to extracting last word. It's like it's a bit complicated. I'm not covering here. So if you have to work with extracting the last um, word, you can use directly str underscore end from the packet. That is the best way. No need of going to base R. So I'm just leaving here. Next is trim and pad string. Okay, this is also important because we usually pad our dates with the let's say when we do imputation in Adams, right? We pad our date with 0 or 00. Sometime in the imputation we usually do that, right? So how we can do that with Stringr package? For Stringr ADAE, and in that mutate. Okay, now for the trim, I'm first I'm using trim function. Okay, AE decode underscore trim. New variable I'm creating. str simple function trim AE decode. Okay, this is a function I'm using. Okay, quickly what this function will do, this will remove extra spaces from start and the end of the string. Okay, so we can use this. And next is next. Okay, sorry, I have to create one more variable, that is AE decode underscore pad. Like padding we do in our Adam datasets for imputation, it's similar. So this is very important function. So I'm just AE decode this variable, and let's say width. I want to set the width. I'll show you how it will come. Side, on which side I want to do padding, right? Let's say you want to do imputation in date. So in the first and in the right, or in the first, like on the left, you want to import do imputation with 0. So you have to pad your first digit with 0, let's say. So you can tell R on which side you want to do padding. Okay, so let's say I want to do in right. Okay, what you want to pad with period, because this is uh, character uh, variable. So just now run. Okay, look, this is okay. Have to first. You can add this assign this variable to the data. Okay, now run ADAE, this one. So trim will remove all the leading and tail spaces, start and the end, and what this pad will do, it will add period. How many times? Look, 20 times I want um, this period it should be added to my AE code on the right side. So so width is not like that, like not 20 times, like till 20. I want my output. Look, how many character is this? How many headache is 1, 2, 3, 4, 5, 6, 7, 8. Now it will add till the width of this value is 20. So that's why for a mild headache, this period we added like very less, but for headache is more, because this already character width is less. So till it will stop when width of that particular value is 20. So by this you can adjust the width, side, and what you want to pad. This is very important function with clinical domain perspective. So these both. So trim also, we usually use trim for removing leading and trailing spaces, and str pad for getting or doing imputation in atoms. So this is very important. How we can do with the base R. Now this is base R example. Okay, in AD AE underscore base dollar symbol, I want to create a new variable, that is first is this assigning. Now in base R we have trim. This we have white spaces, trim white spaces. I don't want white spaces in the starting as well as in the ending, so I'm just removing that. On which variable you want to apply this? You want to apply this on AE decode. Just one. So this will work. Okay, there is you can't see how this function is working, but definitely by this you are removing all the leading and trailing spaces from your data. And now I'm not covering this str underscore pad function in base R because this is very complicated. So I'm just leaving it here. And if you want to pad, you can use str underscore pad. This is the best way. And if you go with the base R, it's very complicated. So no need of going in that complication on these things. So just stick with the str underscore pad function. Now coming to the row indexes of strings matching a pattern. So basically this is similar to index and find function as we use in SAS. So how we can do in R. So we have one function str underscore which. So let's say row. I want to create one vector. Okay. And I want to apply str underscore which function, and I want to AE subset data AE decode. This is for basically this is for QC purpose, right? Just a minute, AD AE. Okay. This is for QC purpose. You can do check. Yeah, this variable I want to work with and which string I want to fill. Okay, just first run and see how the output we are getting. Look, 3. Look, why 3? Because go to the AE decode. AE decode, I want to search for the pain string, and on the third observation I have. That's why it's giving me the 3 row index. This is for row index. Third row, we have this pain as a pattern. So pain pattern we are getting at the third observation. So that's why it's giving me 3. So let's say you want to do some QC checks where this string is present, so you can easily do that. But let's say you want to attach or you want to use this with the deployer, like we are doing previously. It will give you it will retain 3 as a value for all the observation. You will get 3 3 3 3 for all the, it will retain that. So this is what we don't want, right? We want wherever trees, wherever the pain string is present, I want the outputs. So for that, you can use string underscore detect function instead of string underscore which function. So this is the function you can do small QC checks. Okay, I'm looking for this string where this string is present and in which observation. So it will give you the row index of that observation. So this is for QC purpose, and if you want the output in your um, data set as a variable, then you have to use str underscore detect function with mutate to get the output. So it will give you okay false false, and it will give you false false and 3 and then false. Wherever the output is present, then it will give you the index, otherwise it will give you the false output. So how we this is the example with the Stringr. Okay. Now how we can do with the base R. Okay. So how we can do this. So with base R, we have to use grapl function, which okay, grapl and then this string which we are looking for, and this data subset AE decode, and then run. Look, we are getting the same row index at the 3. We have pain as a string, pain as a pattern. So this is the method. we can use for um, we can use with str stringr package, and this is how we can do with the base r which function, and same both we can use for the QC purpose to check and look for the particular string, particular pattern in our data, and looking for the index where this data is present. So that's it for today. So this is complete deep dive into a stringr package. Today we learned how to clean, manipulate, and analyze text in a clinical dataset using functions like str detect to flag specific AE term, str underscore split to break text into a meaningful pieces, str underscore trim to remove extra spaces, str underscore pad to pad string to a neat reporting, and str underscore which to locate row with a specific pattern. So these functions are extremely helpful when working with the messy and free text clinical data that we usually get, right? So in the next video, we will move on another tidyverse package to continue building practical workflows. So if you found this video helpful, so please like, share, and subscribe. Thank you for watching. I will see you in my next video. Bye bye.